Hello everyone, welcome to the first tutorial of 4-feed antenna design framework. So in this tutorial I have used IDS ADF design tool. So you can see this, you can go to this website www.idscorporation.com and you can see that there is an antenna design framework for the electromagnetic satellite based applications. So you can see the list of product here. So the main purpose of this IDS antenna design framework is basically in order to simulate large array based design applications. So in this example, so in this first tutorial, what I'll be doing is for a single element 4-feed microstrip antenna design. Okay. So I have considered this paper as a reference for this tutorial. So yeah, so this is the paper which I have considered as a reference for this tutorial. Okay, and you can see that this is the so this is the layout design which they have taken as a reference, and you can see this is the design which they have done using IDS ADF framework. Okay, so you can see the design spec here. Okay, so we have a 4-feed microstrip antenna design with the measurements. Okay, in this case we have considered the length and width of an antenna as 34 mm and the feed line inset distance. Okay, so this distance as 9 mm, and our width of feed line is 4 mm. So this is the one, and this distance, the microstrip feed line, we have considered as 18 mm. Okay, so let us start our tutorial. Okay, so the first thing is that you can see here, this is the ADF EMS shortcut. So double click on this. So now once we have got this toolbar, what we have to do is we need to create a new project. So let us go to project and click on new. So now we'll name this project as 4-feed antenna design. Okay, and if description is necessary, so you can just mention, or else it is not mandatory, so just click on OK. So you will get this new ADF EMS navigation window, and you will get the design area also. Okay, so what we'll do is, so now in order to proceed further, what we need to do is we need to click on this antennas and feeders, that is right click on the antennas and feeders and click on new antenna. Okay, so you will get a pop-up telling that we need to mention the a name of this single element antenna. So what we do here is let us give this as 4-feed antenna design. Okay, and click on OK. Now you will get this plus mark. So what you need to do is just click on this, and you can see that there is a folder which has mentioned 4-feed antenna design, right? So I need to right click on this and what I need to do is I have to click on this create physical model. So when I click this, again we need to mention the name of our analytical physical model. Okay, so what I'll do is I'll just type PHY, that means physical model, and feed antenna design, and we need to mention the ports. Okay, so in this design you can see here that it consists of 4 ports. Okay, so what we'll do is we'll right click on this and we'll give add ports. Okay, and we need to mention the port name. So port 1, right click, port 2, right click, port 3, and port 4. So now we have done with all our ports. Okay, and we need to click on start CAD session. Okay, so now we have got the work environment. Okay, so what we need to do is you can see that in this it has mentioned the current unit as M. So basically what we need to do is we need to change this measure setting. We need to convert this meters into millimeters. Okay, and give the skin tolerance as 0.01 and also mesh tolerance as 0.01. Okay, all the things are perfect, so just click on apply. Okay, so once this is done, you can see that the current unit is in millimeters. Okay, so basically our antennas measurements also are in mm, so we just convert that unit into mm. Okay, so once this is done, what we need to do is next we need to create our physical model. Okay, so in this case, first and the foremost thing is that we require a larger patch. So the large patch is around 34 mm and the width is around 34 mm. So now you can see here that there's something called as add rectangle. So we need to click on this add rectangle, and so here we need to mention it as 34 and 34. Okay, so one more thing is that we need to see the height of a dielectric substrate. So in this design we consider the height of a dielectric substrate as 0.7878 mm. Okay, so what we will do here is we'll just mention the height as 0.7878. Okay, I'll just give preview, so you can see that you can see your rectangular patch. Okay, and click on create. So now we have got this large rectangular patch. So what we need to do is, here you can see that we need to create these slots. Okay, so we already have the measurement as 9 mm. So what I'll do is I'll just click on create new group and I'll mention this as group 2 and click on OK. So the next part will be I need to add those 9 mm feed line insert distance. Okay, So this feed line insert distance. So what I'll do is I'll just create a feed line distance as 9 and this as 8. Okay, and just click on preview and click on create. Now you can see that we have got this a small rectangular patch. So what I'll do is, now we need to create that feed line insert distance, right? So I'll just unmark this geometry of group 1, okay, and I click on this smaller rectangular and I need to manipulate, I need to move this over here. So I'll just click on move skin and I go with coordinates. Okay, so I need to select the start, so I click on this midpoint, so I'll go here, click here, and I need to move this smaller patch over here. So I'll select the end and I click here and just give preview, and you can see that the slot will move here. Okay, so just click on move skin. So this is done. Okay, so what I need to do is I need to place similar feed line insert on the all 4 sides. Okay, so what I'll do is I click on this, I go to copy skin action, I'll select start, click here, this point, and I'll select end. So here, and just preview and copy. So this is done. So similarly, we need to do on the other 2 sides also. So click on this, select start, select the midpoint of this, and select the end. Preview, copy. So select start. Sorry. Select the end. Okay, so we are done with this. So next we know that we need to create the feed line inset, right? So I need to remove this small 9 to 8 rectangular slots. So what I'll do is I'll click on this geometry of group 1, okay, and I select the bigger geometry. We have something called as Boolean. So there are 3 things, that is patch intersection action, patch difference action, and patch union action. So in this case we need to remove these smaller 9 into 8 rectangular slots. So what I do is I click on patch difference action, I uncheck my group 1 and I click on my group 2. So you can see that I have got a feed line inset. Okay, so similarly what we need to do is we need to again select the geometry, select this bigger geometry, click on patch difference, uncheck this and select this. Okay, so similarly we need to perform for the other 2 rectangular, smaller rectangular patch. Okay, so select this total, Okay, so now we got our main patch for our antenna design. So once this is done, we can just delete this group. Okay, so the next part will be that we need to provide 4 feed lines. Okay, so we know that the width of a feed line is 4 mm, and the width of a feed line is around 4 mm, and this length would be around 18. Okay, so what I'll do is I'll again go to create new group, so click OK, and I need to make this base as 18 and my height will be 4. Okay, so I can just give on preview, so you can see that, and just click on create. Okay, so go to top and you can see this. So now what I need to do is I need to move this again. So you know that we need to go to manipulate and click on move skin and click on coordinates, select start and click on this and select the end preview. So you can see that this feed line is present at the edge of this feed line inside distance. So just move the skin and you can see this. So just close this. So what we need to do is again similarly we can copy the skin over here. So select the skin, click on copy skin action, select start, click on this, select end, click on this line over here also. So in this case we need to just change our base to 4 and height to 18. Okay, so give preview and then just create. Go to top and you can see here. So just select this and move the skin. Okay, coordinates, select start, and what we'll do is we'll give this midpoint, select my end, review, move skin. Okay, so you can see we have got this. So again what we need to do is the simple action is just select this and I need to just copy my skin. Select the start, so I need to select this point and select my end, so that will be here, preview, copy. Okay, so now we have got the complete design. Okay, so what we need to do is we'll just save this. Okay, so we have to just give end session. Okay, so once this is done we need to just click on OK button. Okay, so now we are done with this. So our next part of antenna design will be we need to choose an appropriate solver and we need to define the substrate division. Okay, so here we have this physical model. So what we need to do is we have to just right click and we have to go for select modeling method. So in this case we go for full wave methods and we go for 3D antenna modular, that is based on MOM based code for metallic and microstrip antenna. Okay, so I'll select this and I need to define as tool specific model and define your okay, and then just click on modeling session. So now here you can see that MOM, right? So I need to go and click on layer manager and I need to define my substrate condition. So I click on add layer, okay, and I define this layer as substrate and this will be 2.5, and we already know that the thickness is 7.878 mm. Okay, and just click on OK. So we got our substrate. So our lower boundary interface will basically be the ground plane. So I just click here ground plane and select OK. Just save this, and we are done with defining our solvers and substrate definition. So our next part will be we need to define meshing and porting definition. So just click on end session and click on OK. So now you can see that you have got something called as computational model, in which tool and specific model, and you can see that 4 feet you already have a model file. So now right click on this and define on build mesh. Okay, so I'll define this as 4 feet and 10 out. And we need to define our frequency range. So in this case I'll consider it starts from 1 GHz to 3 GHz, and just click on mesh session. Okay, so here you can see that we have two set of groups. So what I need to do is I need to go with the selected groups. Okay, and I select my group 1, and I'll define my meshing as 4 and click on mesh. So you can see that here the meshing is done. Okay, the same thing what I'll do is I will go to group 2 and I define this mesh as 3. So click on mesh. So here you can see that your meshing model is defined. Okay, so here again, I mean, we can change our mesh. So for example, if I need to change this to 3, so what I need to do is first I need to delete all my mesh completely. Okay, so in this way, so again this shows that this is again unmeshed. Okay, so for example I'll give this as 2 and mesh it. Okay, so now here you can see that in this past design I have already defined the mesh models. Okay, so here you can see that I need to select my group, and specifically I can define my meshing. Okay, so in this case I have considered for the larger patch as 4, and the feed line for the feed line patch I have considered as 3. So now once this is done, okay, we need to basically define the ports. Okay, so we need to again go for the MOM, and here you can see that there is port manager. So just click on that, and you can see that I have already defined the set of ports. So what I'll do is I'll just click on reset. Okay, so now I'll show that how we need to define the ports for this. Okay, so now we need to define for port 1, and I need to click on define on surface. Okay, so next what we'll get is we need to add this port over this feed line. So we need to click on this add, and here we need to come here near the edge of the feed line, and we need to click on this. So here you can see that already the port has been defined on this, and I need to just click on OK. So you can see that already the port has been defined. So now we need to also define the ports for the other 4 feed lines. So again what I'll do is just click on port 2, and I'll click on define on surface, click add, click on this. Okay, so similarly I'll do it for port 3 and surface R. Okay, port 4 on surface. Okay, so now we are done with defining all ports on our pass antenna. Okay, so just click on OK. Now here you can see that we have mesh inspect. So this will show us like how many mesh elements we have in this patch antenna design. So I'll just click on compute and you can see that we have around 376 elements. Okay, so next we have checks on mesh. Okay, so here once we run the selected okay, so we can see that there is no error in this. So this means that we can go for our next part of antenna design. Okay, so where we basically try to obtain the S parameter on this, and what we'll do is we'll end this session and we'll give OK. Okay, so now you can see that we have already have our mesh model. Okay, so what we need to do is we need to just right click on this and we need to okay, so we need to come here and we need to right click on this and create the internal model calculation. So I'll just define the last IMA and for free, and I have to define my frequency scan. So I need to just click on this create a new frequency scan. Okay, so define this new frequency scan as frequency scan 2, and we can just go to add and remove the scan points. So I need to define my minimum, that is so we'll change this to hertz. Okay, and we'll go to add and scan remove points. We'll define this as 1 and we'll define maximum as 3, and number of endpoints we'll give it as 21 and click on add. So you can see that we have got this frequency scan points, and just click on OK. Okay, so I have already defined this before, so you can see that here I have already defined as frequency scan point 21. So I'll consider that and I'll just click on OK. So here you can see that you will get a new folder, that is internal model calculation, and you can see a file called as IMA4 feed. So what I will do is I'll just right click on this and I'll start computing. Okay, so now the calculation is going on, and you can also see the percentage of computation which is happening. So here you can see that it has started running, and so it's almost around 95%. Okay, yeah. So now we are done with this. So the calculation has been performed. So let us see our S parameters based result. Okay, so here what we see is, you can see a folder called as S, Y and Z parameter. So here you can see that during the calculation I had given the name as IMA4 feed. So what we need to do is we just need to right click and click on display. Okay, Yeah. So now in this case we will plot with respect to the Cartesian form, and we'll give the scale as decibel. So here we need to select all our frequency scan points and click on port couple as 1, okay, and just click on plot. So here you can see our plot, that is for S11 parameter, okay. So so in this case the return loss, okay, we'll just zoom this. Okay, and okay, so you can see that the return loss in this case is almost around 31 dB for a cutoff frequency of 2.1 gigahertz. So this basically represents how much power is reflected from the antenna. Okay, so for example, if S11 parameter would have been 0 decimal, then all the power would have been reflected from the antenna and nothing is radiated. So in this case we have around minus 31 dB. So this means that the reflected signals are low when we operate in the following cutoff frequency. Okay, so similarly we can plot for port couple, that is for port 2, that is S22 parameter, and just click on plot. So you can see here the following results. Okay, so for port 3 and for port 4. Okay, so now we are done with the S1 parameter calculation. So the next thing which I want to show is to view the radiation pattern for this 4-feed microstrip patch antenna. Okay, so what we need to do is we need to just go to our internal model calculation and we need to right click. Okay, and we need to go near the active pattern calculation. Okay, so click on this and we'll provide the frequency analysis for our cutoff frequency itself. So 2100, and we'll mention this as active pattern analysis for 4-feed antenna. Okay, and we need to create a new excitation. Okay, so you can see okay, you can see here in the active excitation 1. So we have defined the 4 ports, and we'll just define for the port 1, and we mention this as 1 volt. Okay, and this has 50 ohm as allowed. Okay, so once we mention for all the ports, we need to just click on OK. So this is already done. So again, next we need to go for geometry scan. Okay, so what in this case what I have to do is I need to mention the minimum and the maximum angle. Okay, and also the number of endpoints and the number of steps. So for example, I have already defined that before, so we can just see that. So here you can see that the minimum degree is 0 and 90, and the number of endpoint is 91, and I've defined the step as 1, and in this case minus 89, that is for theta, and the maximum I have considered as 89, the number of points is 179. Okay, so what we'll do is we'll just click on OK, and you can see that we have got a new folder called as active pattern calculation. So just right click on this and we need to compute. So once the computation is running, we can just click on this, open the back and procedure control panel. Okay, so here you can see that already this has been performed. So now right click on this and click on display. Okay, so in this section we will consider both the pi and theta, and we'll click on this as total, and we have already defined our cutoff frequency, and we need to do some small changes. So just come to this plots and path projection and just click on this maps to waterfall, and I'll go with linear. Okay, and just click on plot. So once this is done, we'll get our radiation pattern for this 4-feed microstrip patch antenna. So this is the radiation pattern for the antenna. Okay, so I'll just close this. So this is done. So next thing will be that we need to find out active structure current calculation. Okay, so again I need to go near the internal model and right click and click for create analysis for active structure current calculation. So once this is done, click on for 2.1 GHz only, and already we have defined the active excitation in our previous active pattern calculation, and click on OK. So here you can see the active current calculation. Okay, and just right click on this and compute. So the computation has been performed. So we'll right click on this and we'll just click on display. So this shows our current calculation. Okay, so you can see here. So we are done with this tutorial. So